Hi everyone, my name is Jeremy. My partners was Brooklyn, Eliza, and Dustin, and our project was on series convergence. Down below is a link to our Kahoot, as well as the PDF to the note and summary sheet, and the PDF to our worksheet. If you have any questions, feel free to ask us. I am now going to pass it off to Dustin.
All right, what's up? My name is DJ, and I did the note sheet for series convergence. Here it is. It's kind of long. I'm gonna put it up piece by piece so you guys can be able to see it. First off, we have the definitions. We have a series. It's usually in the form A of n. Next up, we have partial sums. So that's in the form of S of n. So we have converges and diverges. So on the note sheet, we have the convergence test, and that pretty much takes up the rest of the sheet. So first off, we have the divergence test. So pretty much a series diverges if the limit of A of n as n approaches infinity doesn't equal 0, then it diverges. Next up, we have the integral test. So here, the series is going to equal f of n, and the function has to be positive, continuous, and decreasing. Put f of n into an integral from 1 to infinity. And then if that integral converges, then the series converges. Next up, we have the comparison test. Here, you're going to compare A of n to another known series, B of n. If B of n converges, A of n is going to converge. Next up, we have the limit comparison test. Pretty much taking the limit of A of n over B of n as n approaches infinity. And if that equals a finite number, then A of n and B of n are going to both converge or diverge. And these next two are pretty similar to each other. We have the ratio test. So here you're going to take an plus 1 and put it over an and take the absolute value of that. Then you're going to take the limit as n approaches infinity. Then for the root test, it's pretty much the same test. You're just doing a different limit. Pretty much you're taking the limit as n approaches infinity for the nth root of absolute value of A of n. And if L is less than 1, then it's going to converge. If L is greater than 1, it diverges. If L equals 1, it's going to be inconclusive. We have the alternating series test. What stands out about is the -1 to the power of n. That's pretty much your red flag to use this test, and it converges if and only if the series is positive, decreasing, and the limit as n approaches infinity equals 0. In order for a series to absolutely converge, so the series of the absolute value of A of n has to converge, and then the series of A of n has to also converge as well. So for it to conditionally converge, the series of A of n has to converge, but the series of the absolute value of A of n doesn't have to converge. So that's pretty much the whole note sheet. I tried to keep it as simple and readable as possible, so yeah.
Here I have a worksheet on the series of convergence. It is 11 problems. The first 7 problems are going to be determining whether or not the series converges or diverges, and that is using one of the tests, such as the ratio test, root test, limit comparison test, integral test, the alternating series test, the p-series test, the geometric series test. So you're just going to give your best statement, and based on your statement, you're going to give whether or not the series converges or diverges, and then show your work as to why it converges or diverges. The next 2 problems I have are specifically on the geometric series test, because the geometric series test has a specific another step, which is after you find that the series converges. Due to the geometric series test, you can find where it converges to by using the sum formula. And then the last 2 problems, which take up most of the time, is determining the interval and radius of convergence, which is through our power series. So I have 2 problems based on that, and after showing all your work, you can determine whether or not, or you can determine where the interval and the radius of convergence is at. So 11 problems, it takes roughly around 30 minutes to complete, and we're going to post it in a PDF format so you guys can read it very easily. And I also have an answer key that we have all went over and figured out that it's actually the right answer key. And you guys can ask us for any questions or guidance so we can guide you through the problems if you guys need any help.
Hi, my name is Brooklyn.
I'm Eliza.
And we chose to do a game through Kahoot. As you know, our topic is about series convergence. So we did 4 different types of questions in this Kahoot. The first type of question is which test works best for this series. You're going to get 4 different types of series convergence tests, such as the root test, ratio test, p-series, and you just choose from those options which works best for series given. You will get 1 minute to answer that question. The second type of question is, does the series converge or diverge? Again, given a series, and you have to determine whether it converges absolutely, converges conditionally, or it converges, or it diverges. You are also given a minute to do these questions.
Okay, so for the next question, it is what is the interval of convergence for these series? So for this type of question, there's two, and there's two questions for this question, and you are given 4 minutes to answer them. And then for the next question is, what is the radius of convergence? Just like the interval of convergence, there are two questions for this, and you are also given 4 options to choose from, and you're also given 4 minutes. That's it.
Kahoot, thank you.
Thank you.